Hello everyone, welcome back. Now we are starting module 2, tool system development, where we will be extending our agent's capabilities. Today we will be working on our base tool interface implementation. This is being the foundation that will be allowing our agent to work with different tools in a standardized way. We will be working on our abstract base class design. This standardization is allowing our agent brain to work with any tool without needing custom code for each tool. We will be creating an abstract base class that is defining the contract that all tools must be following. This is enabling unlimited extensibility through consistent interfaces, meaning we can be adding any new tool in the future, and as long as it is following our interface, our agent will be knowing how to use it. Then we will be implementing our JSON schema implementation. JSON schemas are describing tool parameters for LLM function calling. We will be creating a get1 schema method that is returning parameter definitions and requirements. So our language model is knowing what parameters each tool is expecting. We will also be implementing an execute method that is performing the actual tool functionality with standardized returns. This base tool interface is being crucial because it is creating a consistent way for our agent to interact with any tool, whether it's a calculator, web search, or any other functionality we are adding later. So let's be getting started with building this foundational tool system. In the last session, we are having worked on memory, which is being in our core folder. This session onwards, we will be starting to work on our tools folder, and here we are having three files: basetool.py, calculator.py, and websearch.py. First, we will be setting up our base underscore tool dot y in this session, which will be creating the foundation for all our tools. Then later in the upcoming sessions, we will be working on our calculator tool and web search tool implementations. So let's be getting started with our base underscore tool.py file, where we will be building the abstract base class that all other tools will be inheriting from, and starting to write the code for our base tool interface. First, I am importing the required modules. So I am importing ABC and abstract method from ABC. These are allowing us to create abstract base classes. Then I am importing dict, any, and list from typing. These are helping us with type hints for our code. Next, I am importing base model from Pydantic. This is allowing us to create data models with validation. Now I am creating our tool result class. This class is inheriting from base model, and it is representing the result that is returned by any tool execution. I am defining success as a Boolean field, data as any type that is defaulting to none, error as a string that is defaulting to none, and metadata as a dictionary that is defaulting to an empty dictionary. Next, I am creating our base tool class. This class is inheriting from ABC, making it an abstract base class. This class is being the base class for all our agent tools. First, I am writing the init method. This method is taking name and description parameters, and I am storing them as instance variables self.name, self.description. Now I am creating the get schema abstract method using the abstract method decorator. This method is returning a JSON schema for function calling, and every tool that is inheriting from this base class must be implementing this method. Then I am creating the execute abstract method also with the abstract method decorator. This method is taking keyword arguments and returning a tool result. This method is performing the actual tool functionality, and every tool must be implementing this method. Next, I am creating the getFunction.definition method. This method is returning the OpenAI function calling definition. I am creating a dictionary with type function and a function object containing the name, description, and parameters from our getSchema method. Finally, I am creating the str method. This method is returning a string representation of our tool, combining the name and description. So we are now having our complete base tool interface that all our tools will be inheriting from. So guys, we are now being done with our base tool interface setup. We are having successfully created our abstract base class with tool result model, abstract methods for get, schema, and execute, our function definition method that is working with OpenAI's function calling format. This base tool interface is now being ready to serve as the foundation for all our tools. Every tool we are creating will be inheriting from this base tool class and following the same standardized interface. In the next session, we will be working on our calculator tool implementation with security focus. We will be working on safe code execution with AST. We need to understand that using eval is being extremely dangerous because is allowing arbitrary code execution. Instead, we will be using AST abstract syntax tree parsing that is providing a secure alternative. Having this security first mindset is being essential for building trustworthy AI systems. Then we will be implementing our mathematical operations whitelist. We will be creating a whitelist of safe mathematical operations like ADD, sub, mult, div, and AWU. Our system will be rejecting any operations that are not on this approved list. This is demonstrating safe code execution patterns that we can be using in production environments. This calculator tool is going to be our first practical example of how to build secure tools that our agent can be using safely. See you in the next session where we will be building this secure calculator tool.